Activity 8. Exploring the exponential function. This activity is part of Unit 3, Properties of Quadratic Relations. Let's review the exponent laws. A power is an expression formed with two components. Here's a power. It has n, the exponent, and a, the base. Here's an example of a power. 4 is our exponent. 2 is our base. Here's some other examples of powers. 2 to the exponent 7, x to the exponent 5, 3 to the exponent x, a to the exponent b, 10 to the exponent e, and 10 to the negative 5. Let's review exponent laws. Multiplying powers. A power represents repeated multiplication. So, the product of powers. Let's look at 10 squared times 10 cubed, or 10 to the exponent 2 times 10 to the exponent 3. It's the same thing as saying 10 times 10 times 10 times 10 times 10. This is equal to 10 to the 2 plus 3, or 10 to the 5. Notice that we've added the two exponents together. How about 10 to the 4 times 10 to the 5? 10 times 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 10. That's 10 to the 4 plus 5, which is 10 to the 9. There are 9 tens. So, 10 to the exponent 9. How about 5 to the 3 times 5 to the 2? Here are the 3 5s multiplying together, and the 2 5s multiplying together, and these are multiplying together. So that's 5 to the 3 plus 2, which is 5 to the 5. Finally, 3 to the exponent 5 times 3 to the exponent 6. Here's 3 to the 5 times 3 to the 6. We add the two exponents together and get 3 to the 11. To multiply powers with the same base, keep the base and add the exponents. So, a to the n times a to the m is equal to a to the n plus m. Here are some examples. 2 to the 3 times 2 to the 4 is equal to 2 to the 3 plus 4, or 2 to the 7. X to the 3 times x to the 4 is equal to x to the 3 plus 4. That's the same thing as saying x to the 7. X times x to the 2 is equal to x to the 1 plus 2, which is x to the 3. Here, 2 times x squared plus 5 times x cubed. It's simplified. We multiply the two coefficients, 2 and 5 together, to get 10. And then we add the exponents for the x's, 2 and 3, to get 10x to the 5. Now let's review dividing powers. When we divide powers, for example, 10 to the 6 divided by 10 to the 4, it can be written like this. Here's our 10 to the 6 divided by 10 to the 4. This is equal to 10 to the 6 minus 4. So we get 10 to the exponent 2, or 10 squared. when we divide, we can imagine ourselves crossing out pairs of tens. And what would be left would be 2 tens on the top, therefore 10 squared. How about 10 to the 7 divided by 10 squared? Here's what it would look like if we were to expand it. Simplifying it would be 10 to the 7 minus 2, which is 10 to the 5. 6 to the exponent 9 divided by 6 to the exponent 4 looks like this when it's expanded. Simplified, 6 to the exponent 9 minus 4, or 6 to the 5. 2 to the 5 divided by 2 to the 1. Here it is, as expanded. 2 to the exponent 5 minus 1, which is 2 to the exponent 4. So to divide powers with the same base, we keep the base and subtract the exponents. So a to the n divided by a to the m is equal to a to the n minus m. Here are some examples. X to the exponent 7 divided by x to the exponent 4 is equal to x to the exponent 7 minus 4. Here's x to the 7 divided by x to the 4, and we're left with x to the 3. B to the exponent 3 divided by b to the exponent 4 is equal to b to the exponent 3 minus 4, which results in b to the negative 1. How about negative numbers? Negative 2 to the exponent 3, or negative 2 cubed, is equal to negative 2 times negative 2 times negative 2. That's negative 2 to the 3. Negative times a negative is a positive. Here's a negative taken away. These two make a positive. And this returns it back to negative again. How about when negative 2 is to the exponent 4? Well, it creates positive 2 to the 4. These two make a positive. These two make a positive. And a positive times a positive results in a positive. Negative 2 to the 5. These first two create a positive. It goes back to negative, back to positive, back to negative. So negative 2 to the 5. Negative 2 to the 6. We start off with a negative 2. We multiply it by a negative 2 and it becomes positive. We take that positive number, multiply it by the negative, we get a negative. Times the negative, we get a positive again. Times a negative, we get a negative. And finally, another negative will make it positive. So we can see pairs. These two make a positive number. These two make a positive number. These two make a positive number. So we have 3 positive numbers, which results in a positive answer. So, if the exponent is an even number, then the answer would be positive. So for negative numbers, when the exponent is an even number, then the answer should be positive. If the exponent is an odd number, for a negative base, then the answer would be negative. Compare. Negative 2 to the 4 is equal to negative, in brackets, 2 times 2 times 2 times 2. So it's negative 2 to the 4. So this 4 is attached to the 2, but not to the negative. First, we do what's in the brackets, then we attach the negative. That's different than this. Negative 2 to the 4. This looks like this. Negative 2 times negative 2 times negative 2 times negative 2. That's equal to 2 to the 4. The only difference here is where there are brackets. Here we have brackets, here we don't. So this 4 is attached to negative 2, whereas this first example was only attached to the 2, not to the negative sign. Is the negative sign with the base? That's what we need to pay attention to. For example, the negative sign here is attached to the base. Here again, it's attached to the base. In this first one, since it's an odd exponent, then we're going to have a negative answer. And here, since the exponent is even, an even number, then our answer will be positive. Here we have an even number, so our answer will be positive. Here we have negative 3 to the 4. That's equal to negative 3 to the 4. The answer will be negative. So where this one was positive, this one will be negative. All due to the fact that this one has brackets that make sure the negative is attached to the base. Here, the negative is not attached to the base. Let's review the exponent laws related to the zero exponent. 10 to the 4 divided by 10 to the 4 here is in quotient form. It's been expanded, and it equals 10 to the exponent 4 minus 4. And the result is 1. So 10 to the 0. 10 to the 2 divided by 10 to the 2. This is what it looks like when you expand it. Here this equals 10 to the exponent 2 minus 2. This equals 1. 100 divided by 100 is 1. We write 10 to the 0. The same goes for this example. 6 to the 4 divided by 6 to the 4. Here's our 6 to the 4 divided by 6 to the 4. This will again equal 1, and our exponent 6 to the exponent 0. 2 divided by 2, we know is 1. 2 to the exponent 1 minus 1. Remember, any time where there is no exponent, we can assume that is 1. 2 to the 1 minus 1 is equal to 1. So 2 to the 0. Any number with the exponent 0 is equal to 1. A can be any number, and when the exponent is 0, it's 1. Here are some examples. X to the 0 is equal to 1. 562 to the 0 is 1. Negative 17 to the exponent 0 is 1. And negative 17 to the 0 is negative 1. Again, paying attention to where the negative sign is attached to. The 0 is attached to the base of 17, which makes it 1, and then the negative sign will change it to a negative number.